Welcome guys to Indomitable Tech. This is your AIML consultant Shaunak, and I am back with another video on data visualization using Python. So in this video we'll be focusing on the Pandas data frame, and Pandas data frame uses matplotlib under the hood. So the graphs that we'll be plotting using Pandas will be making use of matplotlib. So let's jump right in. So in total we'll be discussing 8 graphs: histogram, density curve, bar chart, pie chart, scatter plot, box plot, area plot and line plot. Also one more thing, I'll be uploading this notebook and another notebook which is exactly similar to this on GitHub. One notebook will be solved and another one will be unsolved. So the notebook in its current state before in which we are going to write the code, it will be unsolved. So if you want to practice, the format is written over here for every plot, and also the example what parameters you can take. So the hint is mentioned over here in case you want to practice along. So let's jump right in. So data types, I'm not sure whether you have watched the first video or not, but there are in total 5 data types: quantitative, ordinal, nominal, temporal and GeoJSON. So quantitative is basically our numeric column. It does not have an order. Ordinal is numeric value but it has an order, and it also can be a date time value as well, but it needs to have order. So for example, let's say you have 10 classes, 1 2 3 4 up to 10, and these follow a proper order. So standard 1, standard as in grade 1, grade 2, grade 3, so they follow an order. So it has an incrementing order up to 10. So such type of example will be termed as ordinal. And nominal is, let's say you have a cricket team in which there are players from 3 countries: England, Australia and South Africa. So if you have a column telling the nationality of the players, which will be either from England, South Africa or Australia, so these values will be termed as nominal because these are not numeric values and they do not depend upon each other as well. Then temporal will be based upon time, and GeoJSON will be based upon the geography, that is the location. So moving on, the dataset that we'll be using for demonstration will be iris dataset, and I'm just going to replace the columns of our dataset with these custom columns: sepal length, sepal width, petal length and petal width, and the last one will be target. So let me just show you how our data frame appears: sepal length, sepal width, petal length and petal width. And in total we have 150 observations. df.shape, that will give you the number of rows, which is 150, and these 5 columns: 1 2 3 4 and 5. Now the first plot that we'll be focusing on is the histogram. So if you refer over here, the code is mentioned over here: df, then feature list, that is you have to pass in your column names over here, and then dot plot kind equal to hist for histogram, and then you have to pass in bins, and alpha is optional, but if you want a better binning of your histogram, then you can mention the appropriate numbers in that particular bin. And alpha is if you are going to plot 2 or more histograms on top of each other. So if those histograms are going to superimpose, at that time you are going to make use of alpha. I'll show you the demonstration of bins and alpha. So let us plot df, and we'll be passing a list of our columns. So we are going to make use of sepal length and petal length. This will be our data frame, and then plot, and here I have to pass in kind equal to hist. And then right now I won't pass any other parameter and directly execute. So if you see, you are getting this histogram of sepal length and petal length, But if you see, this orange is superimposing on top of blue one, and you are not able to see the histogram which is getting superimposed by the orange one. So for that purpose you can make use of this alpha. And if you see, these bars or vertical bars are appearing thick. If you want to increase or decrease the thickness, you can pass in this bins parameter. So right now let us pass in bins as 50 and alpha as 0.5. so if you see, now we have thinner bars, the vertical bars, and if you see over here, the orange one is superimposing on blue, but you are able to see this in a different color because we have decreased the alpha. If we decrease it even further, it gets relatively faint, and you are able to see what the background is, that is the blue bars which are appearing behind this orange one. For our demonstration purpose, I'll keep it to 0.5. And also, if you want to increase the width and height, you can do that as well. You pass in fig size as, for this example, let's keep it 15 and 5. So 15 will be the width and 5 will be the height. And if you want to pass in title, use plt dot title. So plt is nothing but matplotlib. Import matplotlib dot pyplot as plt. So plt.title. So if you have followed the session on matplotlib, in there I have explained how to put the title and x and y axis labels, and then plt.show to show the these values. So plt.title, we are giving the title to our graph. So let's give it histogram of length. So since we both the parameters we are considering are length, sepal length and petal length, and plt.x level, that will be on x axis we are going to consider the measurement, and plt.y level we are going to consider count or frequency, and then plt.show. So if you see, we have this wide graph of length 15 and height 5. We have the title as histogram of lengths. On x-axis measurement is mentioned, and on y-axis count is mentioned. So that's all for histogram. Now moving on to the next example, density curve. So basically format remains the same, similar to what we used here above, just that instead of kind we are making use of KDE, and instead of bins we are not going to make use of bins. Bins are nothing but this vertical cylindrical bars, and since we are going to draw density curve, so density curve are basically curved lines, so we are going to pass only alpha. So df dot let us take the subset of the values, columns that we are going to use: sepal length and petal length. Sepal length, petal length, and then plot kind equal to KDE and alpha equal to, let's plot it as 0.5. So this is how the graph appears. If I want to make the lines darker, I can do that. I'll pass in alpha as 1. And if I want to change the fig size, I can do that. Fig size equal to, let's say again 15 and 5, and df dot title KDE curve, then plt. So this should not be df, it should be plt dot x level. On x axis we will give measurement, and on y axis we will give count, and plt dot show. So if you see over here, we have got this density curve. And one more thing, if you want to change the location of this legend, you can do that as well by passing plt dot legend, and here you have to pass in lock equal to, by default 1 is on the top right. If you pass in 2, it will appear on top left. Similarly, if you keep on changing the number, it will appear at different places. for 5, yeah, so in center right now it is appearing for 5. So that's about density curve. Now moving on, bar chart. So again, this is the format for bar chart. It is very simple, everything remains the same, just kind equal to bar, and stacked equal to true. This is not a necessary attribute, it is an optional attribute. Df, let me show you. Df dot plot kind equal to, let me execute this, because for this purpose we are going to make use of this bar df. Let me show you how it appears. We are going to make use of mean values for this sepal length, sepal width, petal length and petal width. And since we have 0, 1, 2 are nothing but targets, so since we have three targets, we will be getting 3 bars or 3 differentiations in our bars. So instead of df plot, we will be making use of this bar df and kind equal to bar. And by default, if you see, we are not getting a stacked bar chart. If you want to get it a stacked bar chart, then you have to pass in stacked as true. Now we are getting a stacked bar chart. Now if you want to increase the fixed size, it is exactly similar to the example we saw above. Fixed size equal to, let's say 15, and instead of 15 let's keep it 10, and the height will be 5. And other things like plt dot title, this will contain the title of our graph, bar chart. Plt dot x level, which will be targets, then plt dot y level, measurements, and then plt dot show. So this is how we have got our bar chart: target 0, target 1, target 2, and these are the measurements. If you want to remove the stacked version, you can remove this attribute of stacked. And we have different for 4 values: sepal length, sepal width, petal length and petal width, the average value of these 3 targets. Just for ease, I'll be mentioning the stack parameter over here, which will be commented out in case you want to know that you can stack the bar charts. Now moving on to the next one, pie chart. So for pie chart, you have to have a data frame where the index will be the nominal value. In our case, nominal values are the target 0, 1 and 2, and the values for this nominal value and the values for these 3 particular targets, nominal values, are 50, 50, 50. So what I have done, I have just counted the number of observations for all these 3 categories, and I have prepared this dataset. Dataset as in I have counted the values and formed this series. So let us plot this. So pi df dot plot kind equal to pi, and that's it. It will plot a pie chart, target 0, 1 and 2. Now if you want to increase the size, you can enter fixed size equal to 5 by 5 and plt dot title count of targets, and then plt dot show. So we have got this title and also increase the size. So that's all for pie chart. Now moving on to scatter plot. So on scatter plot, we'll be plotting one numeric value against another. For this example, we'll be making use of we'll be plotting sepal length versus sepal width, and we'll be changing the color as per the target. So we have 3 targets: df dot plot and kind equal to scatter, and x-axis, let us take sepal length, and on y-axis let us take petal length. Okay, so in example I have taken sepal width. Petal length also works, whichever works, so it is up to you. For example, I'll not take this one, I'll take petal width, sorry, petal length, and we'll use color C equal to target. So in total we have 3 targets. So the scatter plot that we'll be plotting will have 3 types of colors. So color will be changed as per the target, and color map that we'll be making use of is set1. So okay, so I have made a typographical error. It should be LENGTH. Now it should appear. Yeah, so we have got these 3 targets: red, orange and gray. So 0 is red, 1 is orange, and gray is 2. So 0, 1, 2, 3 targets. And if you want to increase the size, use fixed size equal to 15 and 5, and plt dot title scatter plot, then plt dot x label. On x-axis we have sepal length, and on y-axis we have petal, and then plt dot show. There we go, scatter plot of all 150 observations. And this sepal width, since we have used petal length over here, I'll just change this to petal length, so there should not be any confusion. Moving on to box plot. So box plot is basically used to find if we have any outliers in our numerical data, to get the mean IQR, that is interquartile range, and whether we have any outliers in our data. For that purpose we use box plot. Again, the format is very simple, df.plot, and in that you have to pass in the kind as box. I have prepared this data frame, box df. What I have done is I have just removed the target, because we have 4 numerical columns: sepal length, width, petal length, width, and the 5th column was target, which was a nominal column, so I have removed that particular column. Now let us plot it. Box df.plot kind equal to box, and that's all. So if you see, we have got these 4 box plots. So 4 plots in this 4 boxes in this particular box plot. First one is for sepal length, next sepal width, petal length, petal width, and if you see over here, these are circles 1, 2, 3. So these are the outliers. This green horizontal line is the median, and this value, the box, the length of this box over here, or the height of the box, what you want to call it, so that is the interquartile range. And the top marking and the bottom marking, these are the maximum and minimum values, and beyond these values you will get the outliers. Now if you want, let us increase the size for better viewing. So 15 and 6, plt dot title box plot of numeric columns, plt dot x label, and x label is name of columns, and plt dot y label is the measurement of items, and plt dot show. Yeah, so if you see, we have 1, 2, 3, 4 outliers in sepal width. In the remaining 3 numeric columns we don't have outliers. That's it for box plot. Now moving on to area plot. I have not mentioned the format over here. So what we will do, we will plot the area plot and then we'll enter the format over here. So for this I have created this data frame, which is exactly similar to the data frame we used above. That is the data frame without the target, which is the nominal column. Only for convenience purpose I have renamed this as, saved this as area data frame, area df, since it is relevant to area plot. So let us plot it. Dot plot kind equal to area, and we should get a area plot. So if you see, blue is for sepal length, orange is for sepal width, green is for sepal petal length, and red is for petal width. Now if I want to increase fixed size for better viewing, let us give it 15 and 5, and plt dot title area plot plt dot x label. We have observation because this is an incremental value for area plot, observation 0 to 150, and on y-axis we have the measurement. So x label observations 0 to 150, and then plt dot y level, on y-axis we have the measurement, and then plt dot show. So now we have a good defined area plot with the title and x and y axis levels. And for, since this notebook I am going to keep it on GitHub for understanding, let me just enter it over here. And this change I'll also make it to the unsolved notebook as well, so don't worry about it in case you are going to try with the unsolved notebook. And the last one is the line plot. So if you refer the top one, it is exactly similar to the top one, just the kind that you have to pass in is the line. So let us plot a line plot df dot. For example, line plot you need to plot considering a numeric column. So df dot sepal length. So sepal length is the column that I am going to consider. Also df dot sepal length and df in square bracket sepal length, both these two things give the same series, that is the content of the column in sepal length. So I have considered this sepal length and then plot kind equal to line, and we have got the line chart. So line plot for this, very simple. And if you want to again plot another one, and instead of sepal length you want to take sepal width, you can do that as well. So we have received two separate line charts. Also if you want to include the other two columns as well, you can do that. You just have to add one more. Instead of sepal length I'll take petal length, so the third one which is in green. So this is how you can draw. And let me just quickly put fixed size as, let's say, 15 and 5, and plt dot title will be line plot, and then plt dot x label. On x-axis we have observations 0 to 150, and then on y-axis we have the measurements, and then plt dot show. And if we can add legend, we can do that as well. So we have got this legend. If you see over here, this small box telling us the color which it is referring to: blue for sepal length, orange for sepal width, green for petal length. So this is how you can plot the line plot using Pandas data frame. So just to recollect all that we have discussed, so this is a notebook which makes use of Pandas data frame to plot the graph directly. Pandas uses matplotlib under the hood to plot its graph. We saw 8 types of graphs in this particular video. First one was histogram, second one density curve, third one bar chart, fourth one pie chart, fifth scatter plot, sixth box plot, seventh area plot, and eighth line plot. So I'll be keeping this notebook on GitHub. If this helps, do let me know by commenting or giving it a thumbs up. This was your AIML consultant Shaunak helping you out with this video on Pandas data frame and how to draw plots using Pandas data frame. I'll see you in the next video, which will be mostly on Folium, and then we'll be concluding this data visualization series using Python with Altair. That's all for this video. You take care. Bye.